All right, guys, so I'm finally getting you some answers to these packets. So I do want to tell you, first things first, I did not make these packets. So if you are struggling and feel some type of way about them, I apologize because it is not my doing. Unfortunately, the way all of this went down, we didn't have a whole lot of time to prepare. So thankfully, a few people in the district got together to make you these packets while your teachers this week and next week could work on what you're going to do online for the following weeks. So if it seems like I have been kind of MIA and not uploading videos for the packets, it's because I've been working on your videos for after the packets. So I apologize on that, but those are done. So now we can kind of get to the packets. So we're going to do one section at a time. Please do not stress over these packets. If there's something that you don't know, please skip it. I've tried to get that message out to everyone every time we've discussed it. So just do what you can. There's plenty. If you even think your answer might be right, just go ahead and jot it down. I'm not going to be too critical when I'm looking over these. All right, so let's go ahead and get started. I actually really liked this very first problem. It says, what do you notice and what do you wonder? So really it's just asking, notice would be what do you see, and wonder would be like, what are some questions you may have? Like if we were in class, Miss Warfel, why doesn't this graph have whatever? And that would be what you're wondering. Okay, so I'm not going to write this one down. I'm not going to write the answers to this one. We're just going to kind of discuss it really quickly. So what do I notice? I notice that this graph is labeled with distance in time in seconds, which we've actually done plenty of those in class. And this graph isn't. So the second graph doesn't have a label for the x-axis and the y-axis. I could notice that this graph is comparing two things. We don't know what they are. One's G and one's F. And this graph is has one thing. If we're talking about distance in time, we're talking about something traveling a certain amount of distance. So one's going faster while another's going slower. You can notice that the graphs are labeled the same on the X and Y axis. We don't know what these values represent because they're not labeled, but we do know that they're numbered the same. I noticed that these three lines aren't the same line. So you have three different functions here. Now, what do I wonder? What are you comparing on this graph? What do these 2 points represent maybe? Why does this line not have any points on it? Why is it not labeled? So things like that. So I believe most of you were able to answer this one correct. There's not a perfect answer because it's asking about you. What do you notice and what do you wonder? You may have had different questions than me. You may have noticed different things from me, and that's amazing. I wish I could hear all of those, but unfortunately we can't right now. All right, so next page. We're going to talk about the ladybug and the ant. So first things first, which I made this problem. I didn't read the beginning, so it's important. A ladybug and an ant move at constant speeds, okay? So constant speeds would be, for instance, if you're driving and you, like, I remember we did this in class. We would walk and then we would stop and then we would walk faster and then we would stop and then we would walk slower. And that is a changing speed, okay? So moving at a constant speed means that you're going the same exact pace. You're not slowing down and you're not speeding up. Okay, so the diagram with ticks marked show the positions at different times. Each tick mark represents 1 centimeter. So I went ahead, and if my starts here, numbering, I went ahead and numbered them just so I could have like some numbers on my graph. So this would be 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And if you want to start at 0, you can. And these really aren't necessary. And you're counting, like you're assuming you're starting at their heads or at their little antennas here. All right, then there's really no questions, okay? So some of you probably didn't number them until you kind of got to the questions on the back, which is totally fine. I'm not going to number every single one of these because they're lined up perfectly. So I know if this is 8 here, it's 8 here, and here, and here. And then if you look at the graph, it has they're traveling in centimeters, they're traveling a number of seconds, and you have two lines, which probably represent your two creatures up here, but we don't know anything about that. And one more thing that you can look at is this is the starting point. They haven't started moving. After 2 seconds, you see that the ant is a little further ahead. At 4 seconds, the ant is still further ahead, and at 6 seconds, the ant is still in the lead, okay? So you probably have some ideas about what that means based on their speed, but we'll talk about that in a second. So unfortunately, I have the packet that some of you have, and they are front and back. So there's going to be a lot of flip-flop in here, and I apologize, but I was not about to print out 400 pages on my copier or my printer. All right, so it says lines U and V also show the position of the two bugs. Which line shows the ladybug's movement and which line shows the ant's movement? Explain your reasoning. I think a lot of you could probably figure this one out for yourself, but we're going to talk about it right now. All right, so let's see if we can get them all in here. Okay, so here we go. Maybe this. Okay, so you have lines U and you have line V, okay? Now this is important. Your x-axis is labeled with centimeters here, okay? So these are the numbers of centimeters. I am going to go ahead and number them because it's just going to be easier for me to kind of see what's going on here. So one thing is the line goes to 24, but if you notice, your ant goes way less than that, so there should be plenty of room. I've already counted, so I know that it'll fit, but you can count and it will fit. So this will be 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Then elapsed time in seconds. You see it only goes up to 6 seconds. There's actually 7 lines here, so that works perfectly. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. Okay, so now I'm just going to kind of look at what my lines are telling me. All right, so we know that after 1 second, line U has traveled 2 centimeters. We know, and I'm just looking at where, here, let me get a color, maybe yellow. All right, so I know, I'm looking at you right now. I know that after 1 second, which we don't have 1 second up here, so let's go ahead and move to 2. After 2 seconds, there's a dot right here for you. So at 2 seconds, this creature, whichever one, went 4 centimeters. So I'm going to come up here and see which, after 2 seconds, which one had moved 4. Well, if I look here, my ladybug had moved 4, because remember, you're counting from the fronts of them. So 1, 2, 3, 4. And you can keep checking this. All right, so the next time is 4. So there's a point right here for you. Sorry, I guess that color, I'm trying not to make like so many dots and stuff on here. All right, so at 4 seconds, this bug had went 8 centimeters. So let's see which one of these went 8 centimeters. And I'm going to look at my 8 right here and go all the way down. And once again, it's my ladybug. You can also count from the start. 1, 2, 3, 4, 5, 6, 7, 8 centimeters in 4 seconds. So we know that line U is the ladybug. So U is the ladybug, which makes V the ant. And I will get a color you can read for this one. V is going to be the ant. Okay, now some of you may be thinking, well, The ant's faster. So why isn't his line going up faster? Because anytime, if you remember back to like the roller coaster activity, you had the roller coaster that was really fast. You had the roller coaster that was a little slower. And then if you remember, it was called the Dragon Wagon. The little baby roller coaster was really slow. This graph is different because you're not talking about time on your x-axis. You're talking about how many centimeters you've traveled versus seconds. So that's going to make your graph look a little bit different. Okay, so we know U is the ladybug, V is the ant. So that is your first answer on the back. U is the ladybug and V is the ant. U is the ladybug and V is the ant. Now, I do want you to explain your reasoning, but we just discussed it. You can, however you did it, I could write, I matched the ladybug traveling to the points on the graph, something like that. And you can even give examples. Okay, so number 2, how long does it take the ladybug to travel 12 centimeters? So how long does it take the ladybug to travel 12 centimeters? Okay, so this is a really important word right here. Constant speed. That means they're not speeding up and they're not slowing down. So what I'm going to look at is this 6 seconds here, because to get to 12 seconds, then it's going to take, then they're going to go double. Does that make sense? All right, so the ladybug at 6 seconds went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 centimeters. And the ant went, let's see if this is 12, 13, 14, 15, 16, 17, 18 centimeters for 6 seconds. So for 12 seconds, the ladybug would go double that. Would go, let's see. So the ladybug would be 12 times 2. Do you guys see that? So if you went 12 centimeters in 6 seconds, another 6 seconds would you do 12. So 12 times 2 would be 24 centimeters. And then the ant, they went 18 centimeters in 6 seconds. So we need another 6 seconds. So we're going to multiply that by 2, or you could add 18 and 18, whichever way. And 18 times 2, let's see, I believe is 36. It is 36 centimeters. So that is your answer for number 2. So the ladybug would have went 24 centimeters. How long does it take? Oh, Lord. How long does it take? Oh, I did this wrong. Oh, the answer is here. I'm sorry. Just like class, messing up. You gotta I don't have you guys to correct me, so I'm making mistakes. I apologize, it's not the answer. All right, so it asks you, how long does it take the ladybug to go 12 centimeters? Well, the line gives you this, so 6 seconds. So ladybug, 6 seconds. I apologize, guys. Now I gotta look at the ant. So we gotta figure out when and where did the ant go 12. So if this is 12 here, this is also 12, and you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the ant went 12 centimeters in only 4 seconds. So the ant, it only took him or her 4 seconds. That means the ant is going faster. Okay, the ladybug is taking her a longer amount of time. Think about if you're walking to class. If it took somebody longer than you to get to class, they're walking slower. If it took you less time to get to class, then you're walking faster. Okay, it says scale the horizontal and vertical axis. That's not what it says. Scale the vertical and horizontal axes by labeling each grid line with a number. You will need to use the time and distance information shown in the tick marked diagrams. We already labeled our graph earlier, so I already did number 3. Number 4, mark and label the point on line U and the point on line V that represent the time and position of each bug after traveling 1 centimeter. Okay? This is super important for you. This is why you needed to label them, because you had to look at 1 centimeter. So let's see if I have another color somewhere. All right, let's use green. Okay, so we need to look at 1 centimeter, not 1 second. So we're looking here at 1 centimeter, so 1 centimeter. This would be the ant, and this point would be the ladybug. Okay, so these are the points we're talking about here. Let's see, what does it actually ask? Mark and label the point on line U. Okay, did it, check. Oops. Did that, mark and label, it doesn't ask for anything else. All right, so number 1, how fast is each bug traveling? So we're gonna look here. Okay, so how fast each bug is traveling, we're gonna look at speed. Okay, so we've talked about speed in the classroom, and what I use and what most of you know for speed is like when you're driving, which you're not technically driving, your parents are driving, let's all hope. So you're looking at miles per hour. Okay, well here it's not miles per hour. Here our distance is centimeters, so we're really looking at centimeters per second. And the way that speed is calculated is your distance. How are you measuring the distance? And time. So you want to set it up centimeters per second. All right, so they don't give us up, so let's go up to the top. You can use the graph for this. It's the same exact information. I kind of like this part up here a little bit better. So for the ladybug and the ant. All right, so for the ladybug, they give us 2 seconds. So we're going to put seconds on the bottom here. Sorry, let me move this up a little bit. We're going to put seconds on the bottom. So in 2 seconds, the ladybug goes 1, 2, 3, 4 centimeters. Okay? Now, the only thing with this is that you usually don't talk about 2 seconds. It's not like you go 40 miles in 2 hours. This line means per. So per usually means 1. So what we need to do is we need to figure out how fast they go in 1 second. All right, and what you were technically are doing here, which we have done in class, is you're reducing this fraction. 4/2 is a fraction. It's also the rate in which this ladybug is moving. So what you would do to reduce a fraction is you're going to either divide or multiply. We know 2, you have to divide to get to 1, so we're going to do 2 divided by 2 is 1. And then you would do the same thing to the top. So 4 divided by 2 is 2. So the ladybug is traveling at 2 centimeters per 1 second. Now let's look at the ant. I'm sorry, my video, I'm having to like go back and forth here because I'm at the bottom of the page. All right, so we're gonna do the same thing because it gives us 2 seconds up here at the top. So we're gonna start with 2 seconds, but let's see how far the ant went. The ant went 1, 2, 3, 4, 5, 6 centimeters in 2 seconds. Okay, so we got to figure out its speed. Same thing again. You don't want for 2 seconds, just like you don't want for 2 miles. That doesn't really tell you how fast something's going. You need per 1. So we want to know how much they're going in 1 second. Once again, you divide by 2. Up here, you divide by 2. 6 divided by 2 is 3 centimeters in 1 second. So the ant is traveling further in the same amount of time, so that means it is going faster. So the ant is going 3 centimeters per 1 second, and the ladybug is going only 2 centimeters per 1 second. Okay, so if they're going at a constant speed here, constant speed, I almost skipped number 2. However, it is a good question, and it's really not as hard as some of you may think it is. Okay, so you can kind of look at this. You could create a table for this if you wanted to, and to kind of analyze just to get some numbers down if you wanted to at first. So let's start with the ant. So if he goes, let's do centimeters and seconds. So if he goes 3 centimeters in 1 second, he's going to go 6 in 2, and another 3 would be 9 in 3, and it's just going to keep on going at that rate. Okay, the ladybug, centimeters per second. Ladybug is going to go 2 centimeters in 1 second, 4 centimeters in 2 seconds, 6 centimeters in 3 seconds, and so on. So it's asking here, is it ever going to be, what does it say? Does it say double? There. It's twice. So they use the word twice. Twice, double. Is there ever going to be a time that this number is going to be double that? And here, I'll draw my lines. So this is going up by 3 every time. This is going up by 4 every time. My bad, 2 every time. Is it ever going to be double? And if you look at this, 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. Because the rate is 3 divided by 1, which is 3. The ladybug, no matter how many seconds she's traveling for, she could go for days. 2 divided by 1 is 2. 4 divided by 2 is 2. 6 divided by 3 is 2. You're going to stay at this rate. So none of this matters. We want to look at this rate. Is this ant ever going to be going twice as fast as this ladybug? And you should be thinking no, because twice as fast, it would be 4 centimeters per second. And this is the rate that they're staying. They're not speeding up. They're not slowing down. So the answer would be no. And explain your reasoning. I'm not going to write all this down. After I did all this, I don't have room. You can draw a little arrow and put some answers wherever you want to. But no, the ant's speed is 3 centimeters per 1 second. And that is not twice the ladybug. For it to be twice as fast, it would have to be 4 centimeters per second. Okay, so now 1.3. Imagine a bug that is moving twice as fast as the ladybug on each tick mark diagram. Mark the position of this bug. Okay, so since we already have this table going, you don't have to do this. I'm going to do this just because we've already started this, so I think you seeing twice as fast on a table may help you a little bit. All right, so this is the new bug. And it's going twice as fast as the ladybug, so we're still going to do centimeters and seconds. All right, so in 1 second, if they're going twice as fast, they're going to cover twice as much ground. So instead of 2 centimeters, this bug's going to go 4 centimeters. In 2 seconds, instead of going 4 centimeters, it's going to go 8. In 3 seconds, instead of going 6, it's going to go 12. In 4 seconds, instead of, what would the next number be? If you kept going up, this is increasing by 4 each time. So this next number would be 8. So that'd be 16. 5 would be 20. And you all are very good at tables. You can keep this going for days and days. All right, so let's go ahead, and it says that we need to get this bug on our chart here. All right, so let's kind of copy this over. So we have 4 centimeters and 1 second. 1 second. Then you have 2 and 8, 3 and 12, 4 and 16. 5 and 20. So this is the new bug. I just copied this so I don't have to keep flipping. It's driving me nuts. All right, what's our new bug gonna look like? Let's do a spider. We'll make it purple. All right, so they're gonna start 1, 2, 3, 4, 1, 2, 3. All right, my new bug is gonna start at 0 with the rest of them. Then after 2 seconds, our bug's going to go 8 centimeters. It's going to go twice that of the ladybug. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to talk about from the front of its legs. All right, so our bug's going to be there at 8 centimeters. Okay, then we're going to do the same thing here. If the ladybug in 4 centimeters, because we have our table, we kind of already know it's 16. You can also just count. So it's 1, 2, 3, 4, 5, 6, 7, 8. And if it's twice, 8 and 8 make 16. So 8, 9, 10, 11, 12, 13, 14, 15, 16. So now our spider's going to be here at 16 centimeters. Okay. And then at 12, let's see, 6 seconds, my bad. At 6 seconds, I believe it'll be off the graph. Maybe not. At 6 seconds, it's going to be 24. So let's see here if there's enough room. So if this is 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, look at that. It's like they had a plan. All right, so it's twice as fast. So that means from the start, and now that I think we're almost done with this problem. So now I can like really draw a line, like really look at it. All right, so from the start, if it's going twice as fast, that means that it should go double the distance. So 1, 2. So this distance should be about the same. 1, 2, 1, 2. And it does. It looks like it went twice as far, double. Okay. Let's see here. Blah, blah, blah. We mark the position. Check. And to plot this bug's positions on the coordinate axis with the U and V and connect to the line. Okay, so now all we need to do is take this data that we drew up here, just like we did, just kind of like we did with these dots. We're going to actually just create the line here. Okay, so we know and we're going to do purple since this is a spider. So we know they start at 0, 0 with the rest of the bugs, okay? Then at 2 seconds, the spider was at 8 centimeters, okay? So at 2 seconds, this bug was at 8. So you got to match 2 with 8. So this was the spider. All right. At 4 seconds, so this is 4 in seconds. And I know a lot of you are going to try to match it up the other way, but you have to look at what you're comparing here. You got to start with seconds. 4 seconds, it's going to go 16 centimeters. So you got to find 16 on the centimeters. And you are going to put a dot at 4 and 16. And then that is all that our graph can fit because it only goes to 20. So that's perfectly fine. If you guys like have a book or heck, some of you may have a ruler, that would be nice. I have a pad of paper. Let's see. Anything that's straight. If not, then just do your very best. It's okay. So this is going to be the spider. All right, so like we did, like I discussed before, in graphs that we've done in class, we've always done time versus distance. We flip-flop the X and Y axes. That's why the faster creature would be going higher and then the slower one would be lower. But because they flipped it, the faster creature, because this is ahead of the ant every time, that means the spider is faster. The ant is kind of in second place and the ladybug is the slowest. So the spider's going quickly. It's traveling a lot of distance in a little amount of time. The ant is not traveling as much and the ladybug is traveling much slower. All right, so okay, we are so close to being done. All right, so I actually am excited about this question because we did this a long time ago. You guys were really, really good at it when we did it, but I'm sure most of you have forgotten it. So it says write an equation for each line. If you remember our equation of all lines where y equals mx plus b, where b was the start on the y-axis, and then m, hopefully you're saying slope in your head, was the slope, which is rise over run. Which I probably should have done this over here. But let's start with the ladybug. All right, so super easy. Y equals, we know our slope, x plus where it starts. Well, the most amazing thing about all of these graphs is they all start where? At 0. So super fabulous, plus 0. So you can actually, we'll do the ant in green this time. The ant, you can go ahead and set up all of your equations. Leave a blank for your slope because we haven't done that yet. X plus 0 because they all start at exactly, and I used a spider, whatever your creature is, you can use that one there. This is the new one. Y equals blank x plus 0. Now, if you're getting super fancy, you remember you don't actually need, sorry, oops, there we go. We don't need that +0 because plus nothing, you don't actually have to have that there. However, it is correct if you do have it. Now let's start looking at our slope. You can do slope many different ways because they're fractions and fractions are equivalent. So it's totally however you want to do it. I would do it to points that are actually on the graph. So looking at this ladybug, this is like the points where they perfectly cross. I would go ahead and start adding your points there. And would we do the ant in green? All right, so green, this is our first point, this is our second point, third point, fourth point. And then we have the points for our spider. Okay, so it's asking you how many you rise and how many you run. Well, if I go up 1 second, we're looking at the ladybug, so we're looking at red. We go up 1, what does that match with? That point matches with 2. So that's gonna be our slope. We went up 1 and over 2. And if you wanna make sure, and you can kind of write up here, the slope is gonna be up seconds over centimeters. You went up 1 second over 2 centimeters. Okay. All right, let's flip back to the ant. Okay, so the ant's in green. All right, so once again, we're looking at the first point from the start. So you went up 1 and over 1, 2, 3. Because we're counting by ones, it makes that really easy. So you went up 1 second and over 3 centimeters. And last but not least, our spider. This is our first, let's see. You know what? It looks like there's a point here, but we don't want to assume. So if we know, we can do a little side work. So here's our spider. Just like we did our reducing over here. So we know that it went 8 centimeters in 2 seconds. And if you divide by 2, like we did before, then you know it goes 4 centimeters in 1 second. So that actually is a point on our graph. So our reduced slope would be up 1 over 4, but you could do 2 over 8 because you're talking about the same exact slope because the fractions are the same. So up 1 over 4 because that is the actual first point on our graph. Okay, so, Jiminy Criminy. 32 minutes later, and we have finally gotten through the first part. So let's go ahead and look at lesson 1 summary. I'm going to try to get all of part 1 in this one video, like everything that kind of goes together. So I know y'all don't have all day to be looking at this, so let's try to get through this quickly. So lesson 1 summary. So it gives you a graph, and this graph looks real rough. Because first of all, you can like barely see things. Some of these lines are darker than others. But let's go ahead and look at the basis of this. So it says, without labels, we can't tell which line is Kieran and which line and which is, I think his name's Mai. Okay, so up here it gives you a story. It says, let's say we know that a longer bike ride, Kieran can ride 4 miles every 16 minutes and Mai can ride 4 miles every 12 minutes. So, you know, you're comparing 2 kids that are riding bikes. However, we can't answer anything because of all of these reasons, or we can't answer any of these questions because they're not labeled. Which graph goes with which rider? Well, we can't match anything up because there's no numbers. Who rides faster? Blah, 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 all these questions. Okay, so now, if we go back here, and this is just kind of teaching you, this was like a little like mini lesson. If you read through all of this, you would be like, oh yeah, we did this in class. All right, now you have time, or you have miles, you have minutes, you have points, and now you can say which graph goes with which rider, because in the very beginning, it told us that Kieran rides 4 miles in 16 minutes. Well, if you go to distance, 4 miles. If you go to time, 16. There's that point there. So you know that is that rider, Kieran. The next one, it says, let's see here. Who's the next guy? If he, blah, blah, blah. My points for the same graph, they give you points, so 1 and 3. So 1 and 3 isn't perfect on the graph, but 4 and 12 is, because you know between 0 and 8 is 4. 8 and 6, so it goes up by 4. So 4, 5, 6, 7, 8, 9, 10, 11, 12. So there would be 12 there. 4 and 12 would be here, so we know this is my. And then you can kind of keep reading through this, but that's just like a kind of a teaching moment right here. Okay, let's look at this problem. Also, these don't go together. I hope you kind of realize this. This graph is actually on the back, so unfortunately it didn't print super great. So it says Pyra jogs at a constant speed, which as a jogger, that is super, super hard because I know I get winded. So I start off and then I slow down and then I can't breathe and then I stop and then I stretch and then I walk. And so so this isn't quite realistic, but let's go ahead and go with it. So Pyra jogs at a constant speed. That means that she's not speeding up and she is not slowing down. And if you've ever ran before, you know that that's hard to do. The relationship between her distance, so now we have distance up here and time down here, is shown on the graph. My bad. Diego bikes at a constant speed twice as fast as Pyra. Sketch the graph showing the relationship between Diego's distance and time. Okay, so we have to think about this. If Diego is going twice as fast, that means he's covering twice as much ground. So for instance, if Pyra was jogging at 5 miles per hour, then Diego would be biking at 10 miles in 1 hour. He'd be going twice the distance. And if you think about that, if you're riding a bike, you should be going faster than someone jogging. If not, you're doing something wrong. All right, so let's look here. I'm going to kind of look at the perfect points on her graph where they cross at grid lines. And then I'm going to go fill in my missing values. So these are counting by 0.1, 0.2, 0.3, 0.4. They're counting by tenths. Here we go 0 to 2, 2 to 4, 4 to 6. You're counting by twos. We prefer counting by one. So I'm just going to go ahead and start numbering ones. 1, 2, 3, 4, 5, 6, 7, and technically that top one would be 8. All right, so she goes 1 mile in 0.2 hours, which is just some minutes. We could do that if we wanted to, but we're not. It takes her 2 miles, 3 miles. Let's look at 1 hour. She goes, oh, hey, I guessed right. She went 5 miles in 1 hour. That's a pretty good jog. That's a reasonable. It's definitely a jog. She's not sprinting. Okay, so now let's look at Diego. We'll do Diego in purple. All right, whoops, sorry. All right, so Diego is going twice as fast. So in 0.2 hours, here, let me show you real quick. If you want to know how many minutes that is, you do 0.2 times the amount of minutes in an hour, which is 60. So we're talking about 12 minutes. So this is technically 6 minutes. This will be 12. You keep going up by sixes. 18, 24, 30. These are all minutes here. Just a little tidbit of information. 36 minutes. Oh, Lord. 42 minutes. 48 minutes. 54 minutes. And then 1 hour would be 60 minutes. That makes sense. All right, so these are just in minutes, if that helps you understand the problem a little bit better. All right, so in 0.2 hours or 12 minutes, she went 1 mile. That means what's double that? If she went 1 mile, he would have to go 2. In 0.4 or 24 minutes, 0.4 hours, she went 2 miles. That means what's twice of 2? 4. That means he'd have to go 4 miles. In 0.6 hours, which would be 36 minutes, she went 3 miles. So what's twice of 3? 3 and 3 makes 6. And then we have room for one more. In 0.8 of an hour, which is getting close to a full hour, right? That's 48 minutes. So if she went 4 miles, he went 8 miles. And then they both have to start at 0. All right, so I guess they don't have to start at 0, but they do start at 0 for comparing. They went twice as far. All right, so that is what your graph should look like. I am really hoping that problem was not the worst in the world. So I really hope that this problem you were able to do. Ladybug and the ant problem, that really wasn't that bad. I hope that some of you kind of got an understanding of that. If my kids that struggle, like that ant problem probably would have been pretty rough, and so hopefully you just kind of grasped it with me. But this one, I'm hoping a lot of you got this problem. Okay, so we need to like remember this so we can write it on the next page, because unfortunately it's like half and half. So you pick Blueberry Farm offers 6 pounds of blueberries for $16.50. That's a lot of blueberries, guys. All right, so we have 6 pounds. So we have 6 pounds. Well, what did we say? $16.50. Okay, so here we go. It says sketch a graph of the relationship between cost and pounds of blueberries. Well, of course, this is going to be perfectly easy. All right, so let's go ahead and plug in our missing values here. So half of 10 pounds would be 5 pounds. So we're counting by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. So what would be really nice is if we could get a number of pounds to show up on here. So or be a perfect point on this graph. So we don't have to estimate, because some of you may have like gone to, like, you may have thought 6 is here and then 16.50 was somewhere in here and put a dot there. And if you did that, you're amazing. And it may not be perfectly accurate, but I'm okay with it. All right, so what I'm going to do is create a table. So let's do pounds and money. All right, so we know 6 pounds, and then another 6 pounds would be 12, and another 6 would be 18 pounds. And we're trying to find one of these numbers so it'll be a perfect point, okay? Or at least we can get maybe a value that matches at least one of them. All right, 18 and another 6 is what, 24? And another 6 is 30, 36. Yeah, what's after that? 42 and 48. Yeah, that's about good. That's good. All right, so then you get your calculator. If you can, then you're just going to keep adding 16.50 every time, but I'm going to not do that. All right, 16.50 plus another 16.50. So this first one is cost 16.50. 12 pounds is going to cost $33, plus another 16.50 is going to cost $49.50, plus another 16.50 is going to cost $66. And mind you guys, 24 pounds of blueberries is like gallons and gallons and gallons and gallons. Like that's a lot of blueberries. You shouldn't need that many blueberries. So that's why it costs a lot of money. Plus 16.50 is $82.50. Plus 16.50 is $99. 2 more. Plus 16.50 is $115.50. Plus 16.50 is $132. Okay, so we want to look and see if there's anything that matches on both. Okay, so we know we have 30 on, 30 is pounds, so we have 30, but we don't have 82.50. 30 is going to be the only one, so we're going to have to estimate here. Okay, so what I'm going to do is I'm going to go through, and for sake of estimating purposes, I'm going to cut these all in half so I know the halfway mark. So between half of 0 and 12 is 6. So these are all going to be increasing by 6. So this is going to be 18. And they're just going to keep adding 6 each time. So 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 6 is 30, plus 6 is 36, plus 6 is 42, plus 6 is 48, plus 6 is 48, 54, plus 6 is 60, plus 6 is 66, Oh, Lord. Plus 6 is 72. Plus 6 is 78. 84 plus 6 would be 90. 96, 98, 108. So that'd be 4. And so that'd be 110, 114, my bad. 114. All right, and we're going to stop there. Okay, so 6 pounds would be right after 5, right? Is 1650. So if this is 18, 16 is going to be right in here. Okay, we know 0 pounds of blueberries cost $0. We're going to start at 0, 0. All right, then we're going to do 12. So if this is 10, that'd be 11. That'd be about 12. So we add that 6. That's 12. Sorry if this is small for you to see. And then 12 goes with 33. So 12, 24, 30, 36. So 33 is going to be about halfway in between there. So it's going to be about there. So all we're doing is taking these values and just estimating to our very best ability. You know that this is a constant rate. Each pound costs $16.50. So you're going, it should be a straight line. It is going to be a straight line. All right, 24, no, we skipped 18. All right, so 15, 16, 17, 18, 19, 20. So 18 is going to be about here. And 49.50. So you're going to go up and try to find some 49.50 should be right after 48. So it's going to be about there. Like literally right after it. Okay. 24 is going to be right before 25. And we're going to go up to 66. Thank goodness there is it's perfectly halfway between. So it's going to be there. And if you see here, we're creating a line. So if you kept doing this, it's going to keep making this line. So you could go ahead and draw a straight line between those points. They're pretty good. But we can keep going. So we finally got to 30. We're going to go to 82.50. So you got to go all the way up and find your 80. So 82 is going to be somewhere between 78 and 84 because it's right before it. 36 is going to be right after 35. Sorry, my hand's getting in the way. You got to go up to 99, which it's nice because we have a 98 in the middle. 99 is going to be right after it. $42 is going to be a little bit after 40. You're going to go up to 115, which is going to be right after 114, somewhere up there. And we're getting done. So my points look pretty good. Clearly, this one is a little off. It's about the only one that doesn't like flip perfect in line. So I'm going to try to match up all my points as good as possible, which I actually did pretty good. I don't know what's going on with 36 and 99. But anyways, this is what it did. This was just a lot of estimating. So that's the only reason that this was hard. If your numbers were on here, you guys could have easily graphed those. You wouldn't have had a problem with that. Okay, let's go on. All right, so this problem is super easy if you have some graph paper. So it says a line contains the point -4, 1, and 4, 6. Decide whether or not each of these points is also on line. This is not multiple choice. You're literally going to check one or mark them off. So here we go. If you have graph paper, you can do this problem. If you don't have graph paper, you are going to skip this problem or you're going to try it. And if you've tried it, you're amazing and wonderful. But truthfully, just do what you can. I personally don't have graph paper with me, so I'm not going to sit here and try to do that for you. If you've done it, then you probably have your answer right. If you haven't done it, then it's all right. All right. So the next problem. The points 2, -4, and XY, A and B all lie on the line. Find the equation relating X and Y. Okay, so this problem. So all it's asking you is for Y equals MX plus B. So it's asking for your starting point on the Y axis. And it's asking for your slope, rise over run. Okay, so, and it gives you 4 points. 1, 2, 3, 4. Okay, same line. So it doesn't matter where you start from. And then this is your y-axis, and we're going to talk about that in a second. So we're not going to start from here because it is not to find our slope, because it is not on a perfect number. Okay, so we're going to look, and we're also going to skip over this point right here because it's also not on a perfect number, and it doesn't even look in the middle. So we're going to skip over that. So what we're going to do is we're going to look at these 3 points, and we're going to try to find the slope between them. And I want you to look real quick at your axes. They are numbered by 1, so thank goodness we just have to go up and over and count. So we're going to start here. Hopefully you can see. 1, 2, 3 up, and 1, 2, 3, 4 over. So let's see, it's the same over here. 1, 2, 3 up, and 1, 2, 3, 4 over. So we know that our slope is up 3, and over 4. So we can already get our equation started. Y equals 3 over 4x plus, now we just need our starting point. So that is going to be this point right here. Now, there is a way for you to get this point using equations, and we didn't make it there this year. So what I want you to do is estimate. Okay, so we're gonna look at it. I'm gonna say it's half. If I were you at home, I'd say it's half. So let's count. So -1, -2, -3, -4, -5, and a half. So this would be -5.5. So my starting point is gonna be -5.5. All right, we haven't done one like this year. So hopefully you could get the slope by yourself. That was the easy part. The easier part, if you understood that you could just count from point to point. And then your starting point, I'm just going to let you estimate for that. It may be right, it may be wrong. I haven't actually figured out the correct answer, but I'll take that from you. Okay, so that is it. Bless. Thank the Lord, because I'm getting exhausted, and I'm sure some of you are exhausted from doing this packet. All right, so this will be the next video. I'm going to kind of take a break for a second and look over some of this. Please, 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 please remember, if you do not know something, I do not need you to freak out. Okay, I do not need you worried about what your grade's going to be. We are going to eventually get back to normal. So this week, I'm doing this video today. It's Friday. This week is practically over, okay? You have next week, which you should be working on the second packet, which is if you got the big packet from school, it's in there. It's just after this one. And then after that, starting on April 13th, we are finally getting back to normal in class. I'll be uploading worksheets that look we're going to go back to scientific notation. So I promise you, we're going to get back to a little bit of normalcy. Everything's uploaded on my website. I'm about to upload this on there now. So just get through what you can on these packets. I'm going to upload as many videos as I can to help you. But if there's something that I haven't answered on here, it is okay. Try it. Do your very, very best. And then I promise you, you are going to be fine. All right. If you're sitting there and haven't even looked at the packet for 2 weeks, that's when we might have a problem. But I need you doing your very best. And if you do, then I promise you, you'll do fine on this. All right. So I miss you guys. I hope you had a great week. Enjoy your weekend. Take a break and stay at home. All right. Bye.